Hello there, this is a pre-calculus video, chapter 2, section 6, combining functions. So this is a summary of the algebra of functions. We have addition, subtraction, multiplication, and division. And I want to focus your attention on the domain portion of this because I believe that this first part is pretty straightforward. We've done it before. We've even done domain before, but it's oftentimes the most complicated part when you're doing combinations of functions. So as we read here, the letter A represents the domain of the f function and the letter B represents the domain of the g function. So what it is saying when he says domain is A intersect B is that if you take the domain of the f function and the domain of the g function and you find that intersection, that will be the domain of the resulting combination, which is f plus, f minus, f times g. And in addition, in the case of division of the functions, then you also want to make sure that g is not equal to 0. So that's basically what that is saying. So we're going to go ahead and go into our first example. And the first thing I'm going to do is identify what the domains are of the original functions, the f and the g. So for my a, the domain of the f function is that x cannot equal 2 because you don't want division by 0. And then for my b function, the domain would be that x would need to be greater than or equal to 0 because you have the square root of x, and that means that you want to be greater than or equal to a negative number, right? You don't want to have to equal a negative number. You can't get the square root of a negative number. So then we go to the algebra portion. It says find the functions f plus g, f minus g, f times g, and f divided by g and their respective domains. So f plus g of x would equal 1 over x minus 2, the f function, plus the g function. And you don't need to simplify that. You can just leave it the way it is. But then as I determine to put the domain here, I need to take the intersection of these two domains. So basically my intersection is going to be that I can equal 0 because I can be greater than or equal to 0, but I don't want to be 2, so I put my open parenthesis there. I can't equal 2, and then I'm going to pick up and go from 2 to positive infinity, and this would be the interval notation of the domain. You can also say that x has to be greater than or equal to 0, and x cannot equal 2 because that's basically the same thing as an intersection. So you can write it down in the interval notation or you can do it this way. Either is fine for your domain. So let's go back and do subtraction. And as you can imagine, it's not going to be much different from what we just did, only that it'll have x minus 2 minus the square root of x, but it will share the same domain as the first one because it's the same intersection for these two functions. And likewise, it's the same for f times g of x, as we saw in the previous slide. You're going to get 1 over x minus 2 times root x. Now in this case, you can at least simplify it to this, root x over x minus 2. Okay? But again, with those three functions, the domain is going to be the intersection of A and B, which we've already found in the first one. So we can go ahead and kind of say ditto, ditto, that these two will also have the same domain. If you want to rewrite it, you can. But I am going to then do our last one, which is usually the one that causes people the most problem. Not that it has to, but it just, it just requires a bit more work. So f divided by g of x, because you already have a fraction, right? So it's probably easier for us to take our f function, and instead of using the division bar, we can use the division symbol, which is divided by root x. And then that will turn into, whenever you're dividing by something, it's the same thing as multiplying by the reciprocal. So then we'll get 1 over x minus 2 times the reciprocal of root x over 1, which would be 1 over root x. And then I can write 1 over root x times x minus 2. That would be as much simplification as you would need. I know that you're used to not seeing square roots in the bottom, but I assure you that in this case it's okay. So then as far as our domain, it's almost the same thing because we are still going to do the intersection of A and B, but in addition to that, we need to make sure that we don't equal 0 on the bottom. So we already took care of the 2 in this portion, in the A portion, but now we have a root x on the bottom. So before it was okay to have equal to 0 for B, because in this scenario, you're not dividing by the square root of x, so you can have x equals 0, the square root of 0 is fine. But in this scenario, you can't have a 0 in the root, because if you have a 0 in the root, now you're dividing by 0. So it's almost the exact same thing, only this time, we're going to say that our domain is going to have not a bracket like it was here, but a parenthesis, meaning that we're not including 0, still not including 2, and that's the only difference in this scenario, is that you don't have to put a bracket here. Or if you're writing it this direction, you're just going to say x is greater than 0 and x not equal to 2. Just make sure that you don't put the equal to on that portion there. And that will take care of part A. So now we need to do part B. And part B, we're going to actually use, I'm going to erase all this domain stuff for now, because all of them say f plus g of 4, 4, 4, 4. So we know that 4 is in the domain of all of these functions, because none of them said we couldn't use 4. So I'm going to erase the domain part, and then just show you how we can, and that's because I'm running out of space, in case you were wondering. We need to find, we're going to use what we already found here, these responses here, and we're going to find f plus g of 4 for part B now. All right, so all that means is you need to plug 4 into this function now that you have just gotten. And I, of course, still want to delete this as well. Okay, so very good. We're going to go here, and so for me to find f plus g of now 4, we're going to put a 4 in the spots where there was an x. This shouldn't be anything too complicated. We've got this going on. So now you have one over 4 minus 2, which is 1/2. And then you have the square root of 4, which is 2, or 4/2. So you can write this as 2.5, or basically 5/2. So we get 5/2 for the first one. And then you want to do the second one here, which is f minus g of 4. And we're going to replace the variable here again. So we have a 4 there and a 4 there. So the only difference between these two is that this is a plus, this is a minus. So instead of having 1/2 plus 2, you have 1/2 minus 2, or basically 1/2 minus 4/2, which is negative 3/2. And then we're going to go into this guy right here, where we want f times g, oops, went a little too crazy there, f times g of x, and we're going to want square root of x over x minus 2. So we're going to go ahead and put 4 in that spot. Okay. So this time we're going to get square root of 4 is 2 over 4 minus 2, which is 2. So you get 1. So we have f times g of x is equal to 1. And then our last one is the f divided by, so we're going to plug that into this little guy right here. So So we're going to do f divided by g of 4 equals 1 over square root of 4 times 4 minus 2. I will get out of your way in a second. So there we go. We're going to put a 4 in these two spots. So we're going to end up with 1 over the square root of 4 is 2 times 2. So you end up with 1/4. Alrighty, and that takes care of example 1 for us. Now we're going to go ahead and go to our next example, and it's kind of a weird one, but I'll walk you through it. We're doing the exact same thing that we just did. We're adding two functions together. In this case, it's called graphical addition, but don't let it scare you. The graphs of f and g are shown in figure 1. Use graphical addition to graph the function f plus g. So since this red curve represents the f function and this blue curve represents the g function, all you really have to do is for any given x value, and I'm just going to go ahead and pick, I don't know, here maybe, maybe there, maybe here. Pick some points on the x-axis. What we're saying is we want to take this y value and that y value, add them together, and then plot that point. Okay, that's all we're doing. But it also makes it easier if you actually have values. So what I'm going to do is I'm not going to cheat per se, but I'm going to make it a little bit easier for myself because they want us to like graph what the addition would look like. So I'm just going to go ahead and maybe create some values here. So I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not perfect, but it'll give me an idea of where the graph is going to be. So what I'm going to do is now, for example, let's just talk about this point here. When x is 0. We know this is 0 because it's the origin. When x is 0, the red y value is 0, and the blue y value, according to my little scale, is roughly 2. So if I were to take 0 plus 2, I would get 2, which means that the addition of the two functions would be 2. So I plot my point right there. X is 0, y is 2. That's where I would put my first point. Now I don't know what this x value is, but I'm going to guesstimate what the y value is here based on my little scale. So I'm going to guesstimate that at this point the red curve is roughly 2. And then I'm going to go to the blue curve, which is really a line, and I'm going to guesstimate that this is 2, 3, that it's 4. Okay, now it's not exactly 4, but I'm going to guesstimate. So if this y value is 4 and this y value is 2, I'm going to add them together and I'm going to get 6. So now I'm going to plot that at this point it's roughly 6. So here's 5, here's 6. So I'm going to go over here and I'm going to put my point there at 6. And then I'm going to come over here and I'm going to guesstimate that this y value is, I don't know, 1.5. Roughly, okay? And so I'm going to take now the blue line and its y value is probably 5. So I'm getting 6.5. So then I'm going to plot the point. There's 5, there's 6.5 is probably right here. So a little bit higher than that one. All right, something like that. And then over here, I'm going to guess that it's a 1 for the red graph. And I'm going to add it to the y value of the blue graph, which I'm thinking is about maybe 6.5. Maybe 6, maybe 7, but close enough. So it's going to be 7.5. So then I'm going to plot over here, 5, 6, 7.5 right here. And you start to see your graph do this kind of like thing. Okay, now you can keep doing stuff like that. You can pick different points in between these if you want to include more so you can get a more accurate depiction of what it looks like. But this is in general kind of what the graph is looking like. So I'm just showing you how you can determine or get this graph because I'm about to show you the actual solution, and they probably did it a little bit with more points basically. If you're wondering how did they get all that, all that detail, the more points you pick in between, the more accurate this graph is going to look. But the idea is that from a graph, most of the time, like on your website, don't get scared, you're going to have values that you're going to be able to tell what the actual value is, and you'll get, it's not going to be like this where you have to create your own scale. It'll already have a scale for you, but in this example it didn't have a scale, so I put one there so that we could kind of go from there. So I want you to see now what the actual graph ends up looking like, and there you go. So you can kind of see that same progression. If we would have kept going with the values that we were using, we would have eventually gotten the same graph. So not a really hard thing to do, but I just didn't want you to get confused when you saw that. Alrighty, so then we're going to move on to composition, which is really the heart of the lesson today. Composition is where you are putting one function inside of the other. In this case, the g function inside of the f function. This is just like a diagram. If you're having a hard time understanding how it works, imagine that a value of x, like 2 for example, goes into the g function and then comes out as something else, and then in turn gets put into the f function. So this is just kind of the circumventing, f of g of x. It's just a diagram that you can have for your notes if you're having a hard time understanding how it works. But again, we did that in Algebra 2, so you should be fairly familiar with it. So I want to go to example 3 and show you how this works in a practical sense. So we have two functions, x squared and x minus 3. Remember again that when we talk about the domain of a composition function, that the domain is based off of the intersection of the two previous functions or original functions. Just want to make sure that we had stated that again. So f of g, I don't necessarily like this little hollow circle symbol, but I always go back to my f of g of x. I just like the way that looks better. And so, sorry, I have to get my color coding going on. You guys know how I need to do that. So like that, so the g function is going to be inside. Then they want me to go in the opposite direction and also find g of f of x. So we'll do both of those. And right now we're going to start with the first. So what I do is I want to go first to my f function, which is x squared. So what I do is instead of the variable, I just put parentheses and then squared. Because I know that this means that I'm going to put something in place of the x. So I don't even write it. And then I replace it with whatever g of x is, which in this case is x minus 3. So I do that. So there's my function. You don't have to simplify it. You don't have to FOIL it all out. You can just leave it like that. But they also want us to find the domain of these functions, right? It says find the functions and their domains. So for the domain, sorry, I was making sure that something was correct. Anyway, the domain is going to be all reals because as we look at these functions, the domain of the f function is all reals because it's a well-behaved polynomial. And the domain of g of x is also all reals because it's also a well-behaved linear function. So that means that the domain for my composition is going to be all reals, yay. All right, so now we want to go and do it the other direction for g of f of x. So that, the g's outside. So now I got to go to my g function. Same thing, I replace the x with parentheses, minus 3. After I do that, I will input the f of x function in place of the x. So f of x is x squared. So now I get that. And I don't necessarily need the parentheses anymore, but I always put them there to begin with so that I make sure that I don't not have them when I do need them. And again, the domain will be all reals because both of those functions are well-behaved polynomial and linear functions. So now, like we did in the example 1, we can use our answer to find f of g of 5. So just don't be confused that you don't put it in the wrong one. We want f of g of 5, so we're not going to use this function because this is g of f. You want to use the f of g function. So f of g of 5 is going to equal parentheses, and then I'm going to put my x minus 3. Okay, so we also don't need these domains anymore. But so just so you have an idea of what I'm doing here, f of g of 5. Ooh, that wasn't good. And that didn't take. Strawberry, strawberry. Okay, so I'm putting a 5 there. So then right here for the x, parentheses, I'm going to put a 5 in the place of the x. And then it's 5 minus 3 squared. So we don't necessarily need these brackets anymore. But again, I always put them in the beginning so that I make sure that I don't skip anything important. So now we're going to go here. And 5 minus 3 is 2. And 2 squared is 4. So f of g of 5 is 4. And then we want to do g of f of 7. But for g of f of 7, we don't want to plug it into this function. We want to plug it into this one. So we're going to go g of f of 7 is going to equal to, the g of f function is right here. We're going to have x squared minus 3. And we're going to replace our x with a 7. And then we get 7 squared is 49, minus 3 is 46. So we have 46 for second part of part B. And that's it, folks. So now we are going to go on to the next one. Almost winding down here. Example 4. In example 4, they want us to find f of g, g of f, not a big deal. But these ones kind of throw people off sometimes because it's f of f and g of g. So it's like, wow, you're putting the function in itself. So we're going to get started with part A. I might have to do part A and then erase it and then do part B and then erase it because I don't have that much space. But we'll see how it goes. So we're going to do f of g of x, and then maybe I can do at least 2 of them. And then over here we can do part B. We'll make this part A, and this is over here g of f. That's kind of what I wanted there. All right. So we want to put over here f of g of x, and over here we want to put g of f of x. Sorry. So if you want, we can then go f is the square root of x, and my inside function is root 2 minus x. Right? So the g function is root 2 minus x. So that goes inside of this square root thing. And then over here, we're going to have a similar scenario. The g function, which is outside, is the square root of 2 minus something. But that something is root x. So you get that. So for part A, you have the square root of 2 minus x. Which I know looks kind of weird, but it's really nothing more than the 4th root of 2 minus x. And I'll show you how, so you don't get all crazy with me. The inside function, we know already how to do fractional exponents. So this is the same thing as 2 minus x to the 1/2 power, right? This is this purple part. And then you have another square root, which is another 1/2 power. And we know that a power raised to a power, you multiply those. So then you get to the 1/4 power, and the 1/4 power is the 4th root of 2 minus x. So this is basically what you get here. Now with this one, it's a little bit harder to try to simplify it that way. So we're not going to, and the reason is because it's not all underneath 2 square roots. So in this case, I wish my pen would do what I want it to. But in this case, you have square root of 2 minus root x. So they're not both in the little house. So in that case, you can just leave it like that, where it's the square root of 2 minus the square root of x. Now, as far as the domains, remember the domain has to be the intersection of both, right? So for part A, or so for the first function, the domain is going to be x greater than or equal to 0. And then what about the second function? For the second function, the domain is going to be x less than or equal to 0. So, in other words, you need, sorry, my book's falling. You need, I'm going to go ahead and put this up here. For A, the domain is x greater than or equal to 0 because that one's pretty straightforward. And if you don't know how to do this one, what's going to happen is you're going to take 2 minus x, and you need that to be greater than or equal to 0. And when you do that, you can add the x to the other side. So x is less than or equal to 2. And I might have said 0 earlier out of habit, but I knew it was less than, so I apologize if I said that wrong. But it's going to be x less than or equal to 2. Again, if 2 is bigger than x, then x is smaller than 2. So I'm just writing it in the right order. So x is greater than or equal to 0, but x has to be less than or equal to 2. So now you have the fourth root, which again, because it's a fourth root, it has the same issues with square roots of negatives that the original one had. So now we have